Hi there, I'm Mr. Kemp. It's so good to see you again. I told you that I'd see you again soon. Welcome to the 7th session in the sequence of lessons about equivalences of fractions, decimals, and percentages. Today, we're going to work on our fluency skills and recall percentage equivalents. You don't need any resources for this lesson apart from something to write on and something to write with. Let's get started. So in the last session, Miss Heaton left you with this practice activity where you had to fill in the missing information for the percentage, fraction, hundred square, and number line representations. So let's have a little look at it. So on the first row, we are given 50%. We are given a shaded hundred square, and we need to work out the fraction and the number line. So shall we see if we got it correct? The missing fraction, of course, is 50 hundredths. The 100 square has been done for us. And on the number line, your arrow is going to be exactly halfway between 0% and 100%. So well done if you got that right. Next row, we are given 25 hundredths and a blank hundred square and a blank number line and a blank percentage box also. So let's see if we can use the 25 hundredths to work out the percentage. This is of course 25%. The 100 square, we needed to shade in 25 squares. So I've shaded in 2 columns of 10 and then half a column of 10, 25 squares. And then I'm going to use my number line from above, from the previous question, to help me with this one, because 25% is exactly halfway between 0% and 50%. So my arrow is going to be about there. I hope you got that one right as well. The next one, 100%, 100% as a fraction. Well, we could write that 2 ways, couldn't we? We could write that as 100 hundredths. Or we could write it as 1 whole, because we know when the numerator and the denominator are equal, it is 1 whole. The 100 square, we would need to colour in the entire 100 square, all 100 squares within that 100 square. And the number line, of course, our arrow needs to be pointing at exactly 100%, not a little bit before or a little bit after, exactly 100%. The last question, a little bit trickier. You've been given 1/5 equals something over 100. You've been given 20 shaded squares within the 100 square, and we have a blank percentage and a blank number line. So let's see if we can figure out what the percentage would be. It would be 20%. 20% is equivalent to 1/5. We could also write 1/5 as 20 hundredths. And on my number line, I'm looking at 25%. I'm looking where my arrow rests on there, and I know my arrow is going to be a little bit before there, so I think my arrow is going to be about there. You might have drawn it around that sort of place also. So well done if you got all those correct. Now, you might remember from the last time that you saw me that we looked at these bar models. Miss Heaton also had a little look at them with you too. Now, I wonder, can we refer to these parts of 1 centimetre using percentages? What would this first one be? Now we can see that 1 centimetre has been divided into 2 equal parts, and we know that the whole would be 100%. So what would half of that whole be? That's right, 50%. So each part would be 50%. I wonder what each one would be in the second bar model. Count how many equal parts the 1 centimetre has been divided into. 10, that's right. So what is the percentage of each part? 10%, that's correct. So each part is 10% of the whole. Okay? And if we were to add all those 10% up or multiply the 10 by 10, we would get 100%, wouldn't we? Now, I wonder if we can use that to help us with the next one. If a bar is divided into 10 equal parts, is worth 10% for each part, then surely we can work out this bar with 5 equal parts. Can we see that there are these two 10% are exactly equal to this one part here? Okay, so each part, of course, is going to be worth, that's right, 20%. 20% each part of this bar model. Well done. Now, do you remember my good friend here? That's right, it's my counting stick. Now, I have to move quite far back for us to see, don't I? Look at this. Can you see it all? Now, remember, I'm using this one without any numbers on because I would like us to focus on the intervals. Do you remember how many parts I have on my counting stick? Yes, I've got 10 equal parts, haven't I? 10 equal parts of my counting stick. So, if I wanted to point out where 10% should go, where should I put my finger? So I'll hold the counting stick. You can pause the video if you want and put your finger where you think 10% would be. That's right. Here's 10%. 10% is my first interval. Okay. Now, how about 30%? How would 30% be? That's right. 30% would be here, wouldn't it? My third interval. 10%, 20%, 30%. That's 30% of the way down the whole of my counting stick. Okay. What about 50%? Yes, 50% would be here, wouldn't it? 10%, 20%, 30%, 40%, 50%. Okay? What do you realise about 50%? What do you notice about where it is on my counting stick? That's right, it's exactly halfway down, isn't it? Halfway down the counting stick. We've got half there and half here. Okay? 50% is there. What about 70%? Where would 70%? Let's see if you can see all of my counting stick. 70%. What do you think where 70% would be? 50% there, isn't it? So we've got 60%, 70%. 70% would be here on my counting stick. That's right. Well done. Oops, nearly dropped it. Remember these number lines? We can see that the percentages are equal to fractions which have a denominator of 100. But we also know, if you remember, that we can find equivalent fractions here by scaling numerator and denominator down by 10. Okay, so I can scale the numerator down by 10. I can divide that by 10 to get 1. Okay, and the same with the denominator. I can scale that down by 10 to get 10. Okay, so we can have these equivalent fractions. Now, can you see that 10% is equivalent to 10 hundredths and also 1/10? And of course, we can also represent this as a decimal because we know that 1/10 is equivalent to 0.1. Okay, what about 30% then? Well, we can see that 30% is equivalent to 30 hundredths or 3/10 or 0.3. What about 60%? Well, we can see that 60% is equivalent to 60 hundredths, 6/10 or 0.6. What do we know about 1? What can you notice about 1 represented on all these number lines? Well, you can see 1 is represented by 100%, 1, 1, and 1, 1 whole. Okay, now how else could we represent that 1 whole on our fractions? That's right, we could represent it as 100 hundredths or 10 tenths, couldn't we? Because we know that the numerator and denominator being the same represents 1 whole. Well done. Now, here's our number line again. I'm going to draw a vertical line right through all of the number lines, and I'd like you to see if you can see all of the equivalences. So here's your first one. So pause the video now and write down the equivalences on this line. Have you got them all? Let's see. So the equivalences on this line are 30%, 30 hundredths or 3/10, and 0.3. Should we try another one? Okay, write down all the the equivalences on this line. Have you got them? Let's see. Of course, we have got 70% is equivalent to 70 hundredths or 7/10, and also equivalent to 0.7. Let's try another. It's about this line. Have you got them? Of course. The equivalences are 90%, 90 hundredths or 9/10, and 0.9. Super work. Now, it's quite easy when the line goes through the numbers, isn't it? But what about here, though? Have a look at where my line is now. Pause the video and have a think what you think the values are. Can you give your answer as a percentage, fraction, and decimal? Welcome back. Shall we see how you did? Let's have a look. So the answers are 35%, 35 hundredths, and 0.35. Now remember, we say this decimal is 0.35. If you remember back to my last lesson, 0.35 wouldn't be accurate, would it? Because 35 is a whole number. I wonder if any of you put 3.5 over 10 for your fraction answer, as well as 35 hundredths. Well, with fractions, we cannot have decimal numerators or denominators, so we can't actually represent this in tenths. Okay, so if my counting, if a line is not on the interval, then it cannot be represented in tenths. So all of these can be represented by tenths. Okay, but if I were to have a value in between these two intervals, then it cannot be represented by tenths. We would only be able to represent it using hundredths. Okay, let's try another one. So pause the video. What values are represented here? Okay, shall we check? I hope none of you have put tenths. Let's see. 65%, 65 hundredths, and 0.65. Well done. Let's do another one. What about here? Pause the video. Okay, shall we see how well you did? Let's see. Of course, 95%, 95 hundredths, and 0.95. Well done. You are such a maths superstar. I cannot believe it. Now, I'm not sure about you, but my electronic devices, like my phone, constantly need recharging. Now, here is what the battery icon on my phone normally looks like. Never full. This is another place we can see percentages in real life, isn't it? Because my phone battery doesn't go from 100% to 90% to 80% and so on. It goes down in increments of 1%. Now, here we can see a battery showing 35%. Okay, now we can see that I've been using my phone a little bit more here, can't we? Because there is less charge left in the battery and it's now only at 9%. Okay, so next time you're on an electronic device, see if you can spot how much battery power is left in your device. I wonder if you're as bad as me. Now, have a look at this table. You've been given the percentage, but you must give the numerator for the fraction equivalence. Now, we know the denominator will be 100, don't we? Because for nearly all of these, it can't be 10. Can you count how many squares would be shaded on 100 squared to represent the percentage? Can you estimate on a number line where the percentage would be? And finally, can you write the decimal equivalent? Pause the video whilst you do that and come back when you're ready to go through the answers. Welcome back. Do you think you've got them all? Shall we check? So for the first one, we were given 80%. What is that as a fraction? Of course, 80 hundredths as a fraction. Now, how many squares did you shade in on the 100 square? 80 squares, of course. Now, I've chosen to do this horizontally, but it doesn't really matter, does it? Because we've got 10 in each column and 10 in each row. So I've decided to shade in 8 rows of 10 to make 80. Now, on a number line, where would you estimate 80% to be? Well, we've got 50% here, haven't we, halfway. So I think 80% is going to be somewhere over here, isn't it? It's going to be certainly closer to 100% than it would be to 0%. Now, I don't think it's going to be right next to 100%. I think maybe around here would be a really good estimate, I think. Now, as a decimal, we could represent the decimal as 0.80, can't we? Not 0.80, remember, because it's not a whole number, 0.80. But do you remember last time when you and I looked at decimals which end in 0? What did we say we could do? That's right, we can remove the 0 and read this number as 0.8 as well, can't we? Okay, let's have a look at the next one. We've got 45%. What is that going to be as a fraction? Of course, 45 hundredths. And on a 100 square, we are going to have to shade in 45 squares, aren't we? Okay, so I've shaded in 4 rows and then half of another row to make 45. On a number line, now we know that 50%, don't we, is going to lie exactly halfway between 0% and 100%. So our 45% is going to be just, I think, just to the left of 50%. So somewhere around here would certainly be a very sensible place, a very sensible estimate of where 45% would be. And finally, as a decimal, we would represent this as 0.45, wouldn't we? Okay. Next one, 31%, represented as a fraction, would be 31 hundredths. And on our 100 square, I would need to shade in 31 squares, wouldn't I? Okay, so I've shaded in 3 rows of 10 and 1 by itself there. Okay, so 31 squares. On a number line again, we know that 50% is here. We're using what we already know, that 50% is going to be about there. 25% would then be halfway between. So I think 31% is just going to be slightly to the right of where we think 25% would be. Okay, so I think somewhere around here would be quite a sensible estimate. It's almost a third, isn't it? Okay, almost a third of the way down our number line. So if we can imagine, if we can visualize this number line being divided into 3 equal parts, it's going to be around there, isn't it? Okay. And finally, as a decimal, we would represent that as 0.31. Finally, 9%. 9% as a fraction would be 9 hundredths. And I would shade in, I wouldn't even shade in 1 row of 10, would I? I would have to shade in slightly less, 1 less, 9 squares I've shaded in there. And on a number line, well, if we imagine this number line being divided into 10 equal parts, so that each interval represented 10%, then we would be able to put our 9% slightly to the left of our first interval, wouldn't we? Okay, so it's going to be very close to 0%. I think somewhere around here would be quite a sensible estimate of where 9% would be. And I wonder how many of you got the decimal correct. Shall we see? 9 hundredths, there we go, 0.09 or 9 hundredths. Well done if you got all of those correct. Really, really impressed. Really proud of you. Well done. Now, do you remember when Mrs. Chambers told you last week that there were some facts that you just need to learn and recall very quickly? Well, it's just the same with the percentage equivalents too. Let's have a look at this table and see if you can fill in the blank parts. Pause the video if you need to and come back for the answers. Okay, you think you've got them? Let's have a look. So, on the first row, our missing decimal is 0.01. On our second row, our missing decimal is 0.1 for 1/10. On our third row, for 0.2 or 20 hundredths or 20%, our missing fraction is, I wonder, 1/5, of course, 1/5. On our next row, our missing decimal is 0.25, of course, equivalent to 1/4. We know that, don't we? On the next row, we've got a half, or 50 over 100, 50 hundredths. What is that as a decimal or a percentage? Of course, 0.5. We could write that as 0.50, couldn't we? But we know we don't need that 0. And as a percentage, it is going to be 50%. Absolutely. And this last row, 75 hundredths or 75%, what is the decimal equivalent, and how else could we write that as a fraction? Well, we could write that as 3/4, couldn't we? And 0.75. Marvellous, well done. Now, your practice activity today is to have a look at these percentages and place them on this blank number line. Think about whether they are close to 0 or 100. Can you estimate where halfway or a quarter of the way along would be to help you? And as a challenge, could you give your answers as fraction and decimal equivalents too? Now, once again, you have been absolutely incredible today. You've listened so well and you've taken part fantastically. You should be so incredibly proud of yourselves because I am so proud of you. So I hope to see you all again very soon. Keep up the great work and keep doing some amazing maths. Speak soon. Bye.